One of the non-linear data structure is called as graph. This is actually a pictorial representation of a graph. The definition is a graph is a collection of points called as vertices. Sometimes it is also called as nodes. This A and C are called as actually vertices here, and these vertices are actually connected by some line segments called as edges or arcs. Graph can be represented as G is equal to V comma E. Here two defined pair of sets are there, V and E. V means actually a finite non-empty set of V. A finite non-empty set of items called as vertices. For example, see here A, C, B, D, E, F. These are called as actually V. A set of V, a pair of these items is called as edges. Here E indicates a pair of these vertices. Okay, next I will explain how actually it will do. Now see here, there are two types of graphs are there. This graph is called as actually undirected graph, and this graph is actually called as directed graph. In undirected graph, the vertices are A, B, C, D, E, F, whereas edge can be represented as AC as well as CA. Okay, AC, CB, BF, FE, ED, AD, CE, like that one. These are actually called as edges of the undirected graph. This is called as directed graph. In directed graph, the vertices are same, A, B, C, D, E, F, but the edges are different pairs. For example, see here AC is there, okay, like that. DA is there, CE is there, DE is there, BC is there. There is no CB, only BC, like that. Okay, like that we can tell vertices as well as edges. Now consider the first one is called as undirected graph. What is the meaning of undirected graph? If all the edges in the graph are undirected, then such graph is called as undirected graph. So what is the meaning of undirected edges? Here if you consider this one as U and this one is V, the pair of vertices UV is same as VU. These two vertices A and C are called as adjacent to each other, and this edge is called as undirected edge. In simple way, if you consider this one as one city and this one as another city, there is a road between them. There is a one path or road. Now I can travel from A to C as well as I can travel from C to A in the same path. So it is called as undirected edge. Now see, A and C are connected here using undirected. So we can say that A and C are incident to this edge. Okay. Now see this graph. This is called as directed graph. In short, it is also called as digraph. In directed graph, each edges are having some direction. If you see here, instead of line, we are indicated by some arrow mark. This part is actually called as tail part, and this part is actually called as head part. in simple way I can say, if there is a path between, if A is a one city, C is another city, if there is a path between A and C, I can travel from only A to C using this path. I cannot go back this like this. I cannot go backside. So such concept will be here. If I considered A as a vertex, for example, if I consider this one as a U and this one is considered as a V, UV vertex, UV edge is not same as VU. In directed graph, these vertices not same. C is not same as CA. Graph representations. Now, this is a pictorial representation of graph. But when we are implementing graph in computer, we have to convert that into a particular format that is called as graph representations, because graph cannot understand this picture. We have to convert that picture into computer understandable format. We can do this by using two techniques, that is called as adjacency matrix and the second one is called as adjacency list. Graph can be represented in computer by using these two techniques. The first one is called as adjacency matrix. Now this is the graph and the adjacency matrix of this graph is written here. So what is the meaning of that one? I will explain first. If we have n number of vertices, we can create a matrix of m into m. For example, if you have n number of vertices, we are creating n into n matrix. Here one row and one column is given to one vertex. For example, see here, this column and this row is given to A. In similar way, this row and this column is given to B. One of the non-linear data structure is called as graph. This matrix of this graph is written here. So what is the meaning of that one? I will explain first. If we have n number of vertices, we can create a matrix of m into m. For example, if you have n number of vertices, we are creating n into n matrix. Here one row and one column is given to one vertex. For example, see here, this column and this row is given to A. In similar way, this row and this column is given to B. If there is a edge between ith element and the jth element, we consider this one is the I, this one is considered as the j. If there is an edge between ith element and jth element, we can represent it by 1. For example, see here, there is an edge between A and C. So A and C here. Okay, we are putting here 1. That indicates that there is an edge. Between C and D, weighted graph. In weighted graph, one of the non-linear column and this row is given to A. In similar way, this row and this column is given to B. If there is a edge between ith element and the jth element, we consider this one as the I, this one is considered as the j. If there is an edge between ith element and jth element, we can represent it by 1. For example, see here, there is an edge between A and C. So A and C here. Okay, we are putting here 1. That indicates that there is an edge. Between C and D, if you see here, C and D, there is no a direct edge here. There is no any direct edge. We have to go from E. If you see here, from C to D, there is no edge here. Okay, now consider here, from C to D, there is no edge. That is indicated by 0. It's very simple. If there is an edge between two vertices, put 1. If there is no edge between two vertices, put 0. See here, A to B, there is no edge. A to C, there is an edge. A to D, there is an edge. See here, A to D, there the edge is there. But A to E and F, there is no edge. We have to go from this direction. So it is indicated as 0. Okay, one more point we have to remember is, in undirected graph, if you see, this is the example, in undirected graph, the vertices, the edges, the matrix is always symmetric. In the undirected graph, the matrix is always symmetric. What is the meaning here? If you see the values above this diagonal, if you see the values above this diagonal, okay, is same as this one. The values which is above the diagonal is same as this one. This happens in the undirected graph. That is represented A I to J is equal to A J to I for every I. Means A to B is 0 here, A to B is 0 here, A to C is 0 here, A to C 0 here. Sorry, A to C is 1, A to C is 1. So symmetric. The next one is called as, sorry here, it is adjacency least. It's not a matrix here, it's a adjacency least. What is the meaning of adjacency least? It's nothing but a collection of least. The second method of representing a graph is called as adjacency least. In adjacency list is actually a collection of linked list. Each linked list here represent one vertex. For example, see, this linked list is actually represent A. Here this linked list is actually a special type of linked list which is having a header part. The header part is actually indicating the vertex. The remaining element in the linked list represent the adjacent node of the vertex. For example, see this linked list, C and D are adjacent node of A. See here, C and D are adjacent node of A. In the similar fashion here, if you see this one here, A, B, E, these nodes are actually adjacent of C. See here, from C, A is adjacent, B is adjacent, E is adjacent. If you see properly, the matrix format and the list format has no any difference. Wherever there is a 1 in the matrix is an element of linked list. For example, see A here, A 1 is there, that is C, 1 is there here, that is D. So linked list also C and D. Weighted graph. In weighted graph, each edges are assigned with some numbers. Sometimes these numbers are called as weights as well as costs. Such graphs are used in many real world applications, such as finding the shortest path between 2 points in a transportation or communication network. For example, if you want to travel from Kumta to Hubli, there are many paths are there. Which path is very short one, that we have to identify. In that case, we need weighted graph. Or in computer networks, we have to transmit some message from one computer to another computer. In between there are many routers are there. So between source to destination there are many paths. Which path is best or shortest, that can be identified using weighted graph. The second real life application is the traveling salesman problem. Like that, there are many many applications are there by which we can solve using weighted graph. Just like normal graph, the weighted graph can also be represented using the two techniques, adjacency matrix and adjacency list. In the first adjacency matrix, if there is an edge between two vertices, in that case we are representing that vertices with some value. For example, if you consider this one is the I and this one is j, between ith and jth element there is a edge having a weight called as 5. So what actually we are doing here is, between A to B there is a edge and its weight is 5. In similar way, there is the edge called as A to C and its weight is 1, so it is nothing but A to C is equal to 1. Since it is a undirected graph, the values are symmetric here. If there is no edge between two vertices, that is indicated by a special symbol called as infinity. For example, see, there is A to D. There is no any separate edge. So A to D is indicated by infinity. C to C as well as D to A, there is no edge. So it is also indicated by infinity. Such graphs are called as weighted matrix. Such matrix are called as weighted matrix or cost matrix. Here, as it explains, there is an edge from ith to jth vertex. If there is an edge from ith to jth vertex, element aij, here element aij will simply contain the weight between these two vertices. Now this phi is written here because there is a edge which is having a weight 5. Now in weighted graph representation using adjacency list. Now this is the way of representing adjacency list. Here each list contains not only the edge name, it also contains here, it not only contains the edge name, it not only contains the vertex name, it also contains the weight. Between A to B, its weight is 5. Between A to C, its weight is 1. This is the way of representing weighted graph using adjacency list. Each element contains not only the vertex, also the edge between these two vertices. The next one is called as paths and cycles. Two important properties we have to remember in graphs is called as connectivity and acyclicity. Both of these properties are actually depending on a notion called as path. First we have to understand what is the meaning of path, because this connectivity and acyclicity is actually depending on path. Okay, what is actually a path? A path from vertex U. You just imagine this one is called as U, and you just imagine this one is called as V. A path from vertex U to vertex V of a graph G can be defined as a sequence of adjacent vertices that start with U and ends with V. For example, if I consider this one as one path here, now from this U to V there are number of adjacent vertices. For example, A to C, C to B, B to F. Now this one is called as one path. Okay, now U to V, there is a number of adjacent vertices. Altogether it is called as path. There are many paths between A to F here. U to V, there are many paths are there. This one is also one type of path here. This one is also one type of path. So there are many paths from U to V. Okay, the next one is simple path. What is the meaning of simple path? If the paths are distinct, if all the vertices of a path are distinct. Distinct means what? there is no any duplicate or repetitions, then such paths are called as simple path. For example, see here, A to C, C to B, and B to F. From A to F, no vertices are duplicated, all are distinct. So A, C, B, F is called as here simple path. Now if I consider this one, A to C, C to E, E to C, C to B, B to F. Now this is not called as a simple path because this C is not distinct here. We use C two times, A, C, E, C, B, F. Now this is not called as a simple path. The next one we have to understand the length of a path. What is the meaning of length of a path? If you consider this one and this one, okay, total number of vertices in the vertex sequence defining the path minus 1. Okay, what is the meaning here is, if you consider this one as one path from A to F, okay, from A to F we are having a path called as A, C, B, F. Okay, what is the length of this path? The length of this path is nothing but total number of vertices here in this path. A, C, B, F. There are totally 4 vertices. Okay, total number of vertices minus 1 means 3. The length of this one is called as, the length of this path is called as 3. In other words, the total number of edges here is also considered as the length of the path. Okay, the length of the path can be calculated either using vertex minus 1 or number of edges between path. The next one is called as connected graph and disconnected or not connected graph. If a graph is said to be connected, if for every pair of its vertices U and V, there is a path from U to V. If you consider this one is U and this one is V, okay, from U to V there is a path is there. Now see, this is one path, this is another path here. If you consider this one as U and this one is V, okay, this one is U and this one is V here, again there is a path is there here, direct path. You can go from here. Means every vertices have path to other vertices. From C I can go to A, B, D. Means this vertex can connect to all the other vertices. This vertex can connect to all the other vertices. So that is called as connected graph. All the vertices are having path between them. Okay, now one more type is there, not connected graph. Sometimes in our real life applications we are also dealing with not connected graph. Okay, now what is the meaning of not connected graph? A graph is not connected if from U to V, there is no a path. If from vertex U to vertex V, sometimes there is no a dedicated path between them. For example, see, this is connected graph here. This is connected graph. For each vertex there is a path between other vertex, here also. But when you consider the total as a one graph, when you consider the total as one graph, now this is disconnected. For example, see here U, here V. Now there is no path here. Now I can go here, but there is no edge between here, so this is not connected graph here. If there is an edge, then it is a connected graph. Next one is called as acyclicity. Acyclicity means we have to check the path within the graph will create a cycle or not. Okay, what is the meaning of that one? A cycle is a path of positive length that starts and ends at the same vertex and does not traverse the same edge more than once. For example, see here, if we are considering this one as one path, here F, G, I, H, F, or reverse order F, H, I, G, F. Now this path will create a cycle. What is the meaning of cycle here? The F will be called more than once, start with the same point here and with the same point here, so it will create the cycle here. So such path is called as cyclic path. For example, see here A to D. Okay, from A to D the path is no cyclic here. Such paths are called as acyclic path because the path will create no cycles here. Okay, acyclicity will be used in some applications like topological problem, like that. In many applications we have to check for the acyclicity. One more time, what is the meaning of cycle here? A cycle means if the vertex traverse more than once in path, the same vertex appear more than once in a path, then we can say it the path is acyclic.